Before we dive into equations or graphs, let's talk about the core building blocks of statistics, the definitions that everything else is built on. First up, data. Data is just information we collect. It could be anything: heights of students, test scores, or how many cups of coffee people drink. On its own, it's raw and unprocessed. But once we start analyzing it, that's when it becomes meaningful. That's statistics. But how do we actually collect data? Here are a few common methods. Surveys, asking people questions, like through forums or polls. Experiments, setting up a situation to measure how things respond, like testing a new teaching method. Observations, simply watching and recording what happens, like counting how many students use the library each day. Existing records, using data that already been collected, like school attendance logs or health records. Next is population. A population refers to the entire group of people, items, or data that you want to study or make conclusions about. If you are trying to find the average height of students in your school, then your population is all the students. But studying everyone can be hard. That's why we take a sample. A sample is a smaller group selected from the population that is actually studied or measured. For example, if the population is all students in your school, a sample might be 50 students chosen from different classes to represent the whole school. Now, let's dig a little deeper into two very important concepts: parameter and sample statistics. Let's say your school has 500 students. You want to know the average height of all of them. If you actually measure every single student and calculate the exact average height, that number is a parameter. If you ask every student their favorite subject and find that 40% like math, that 40% is a parameter. Why? Because it describes the entire population. A parameter is a numeric value that describes a characteristics of the entire population. But let's be honest, measuring all 500 students, that's a lot of work. So you randomly choose 50 students, measure their heights, and calculate the average. That average is a sample statistics. It's a number that describes just the sample, not the whole group. So what we are doing, we use sample statistics to make educated guesses about parameters. If our sample is chosen well, meaning it's random, fair, and large enough, the sample statistics will be very close to the parameter. In the end, let's recap. Data is just raw information. Population is the full group we're studying. Sample is a smaller part of that group. Parameter is a number that describes the whole population. A sample statistics is a number that describes just the sample.